Hi, my name is Miss Beard, and I'm here to help you figure out potentially your first lab report that you've ever written. We're going to look at the first lab that's coming up in chemistry class that's on physical and chemical changes. And overall, the goal for this lab is going to be to understand how physical changes differ from chemical changes and to let you get to experience what some of these may look like. So as you click through and you're completing your warm-up, and your instruction, I'm just going to show you that you're going to need to see. When you get to the instruction part, all labs are going to have a student guide, and you want to click on that and open that up. That's going to be specific for that lab that you're going to complete. When you click and complete the lab, you're going to see some other things a little bit later on, and then I'm going to also include a lab template for you, especially if you have never written a lengthy lab report. I would technically spend several days of class with a lab report in a brick and mortar school. So in my mind, a lab report is something that's substantial and should take more than maybe just 30 minutes of typing to put together a very polished example of one. In this box, you see a lab report guide. So let me take you in for a little closer look. This lab report guide is quite lengthy, but it is a very good document that talks about all the sections that you would want to include in a lab report. And you kind of see an overview right here. And if I were to, in my brain, kind of chunk this into points that the teacher is going to award to a student, the introduction of the lab talks about why we're doing the lab. What question are we investigating? What is our hypothesis or educated guess about what's going to happen? Do we have any variables that we're going to identify in that section? So I would award almost 20 points for that section. Then you've got a lot of meat and potatoes here with the materials. What would I expect to see out on a lab table for me to complete this lab? Even though this is a virtual experience, what would I actually need to replicate this again? And then what steps would I be taking? And in this part, if you pull up your specific lab guide for each lab that Edgenuity publishes, they have a lot of this information to help you write a really great lab report. You can take a look up at the top where they already have a purpose and a question and even a version of a hypothesis for you. You just do not want to copy and paste this directly into your lab report. That would not earn you any points. You would want to reword it or often have a version of your idea that you would make in those statements. But this is great for getting you started for each and any lab, no matter the science class that you are going to conduct. And even here, you've got all the materials that are already listed for you. This is amazing. In a brick and mortar school, I would make my students look at the things physically and have to make a list. So you're just really essentially taking this and moving it into your lab report format. There are even already steps done for you, but you want to write it yourself. And I used to be pretty technical about that and expecting my students to reword these things in their own words, or what did you do when you were clicking through in the experiment? So let's get back to the lengthy guide that they gave you. So that would probably be about 30 points worth. Then we've got the data table where you've collected detailed observations. That's another 30 points. That section may have you include graphs that you would make from your data, and sometimes those are not included. And your analysis and conclusion is where you put together your background information, you recap what you learned about the lab, you restate what your hypothesis or educated guess was, and then you also have to make a statement that the data supported your hypothesis or that the data did not support your hypothesis. Never should you ever use the word, it's correct. That's probably the big science thing. So in this document, it will go into a lot of detail telling you about all of these little portions. I'll let you take the time to read through that. And then again, your specific lab report is going to help you specialize what you're going to write about. And see, this one here for chemical and physical changes has a chart that you can just copy and pop into your lab report. So let me show you that. This I'll need to share with you. And so you're going to make a copy. This one is going to be viewer only, but you would just go to File or Edit, which one is it, and make a copy for you to then highlight and then type and edit using this as a guide. So put the title of your lab report there with your name. And then here again is the introduction part where you would go back to that student guide and rephrase this purpose. Explore the differences between. Use some different words, change it up a little bit. And then rephrase the question and make your own hypothesis. Type that in these sections. Make a bulleted little list of all the materials. You're just copying that from the guide that was already provided for you. Reword and make statements about what you did for the procedures for the lab. And then here again in part 3 is where you put the data table. And this one's where we look at the conclusion, restating your hypothesis. Was it supported or not supported? These last 2 things, sources of error. Sources of error is really being an exceptional thinker when you are going, what could have gone wrong in the lab? Or what might I have done that would have caused my results to not be what was expected or what the norm or the hypothetical yield was? For instance, in my experience as a chemistry teacher, and we had a strip of magnesium metal tape, and what we were doing is we were going to heat it up and it's going to convert it into a different substance. The students had to coil that little ribbon up and put it in a crucible that we closed up and we heated with a Bunsen burner. And you had to keep that coil kind of loose so that oxygen could touch all the surfaces. But I had some student groups that wound it really tight in a little coil and placed it in there, so oxygen couldn't interact with all surface area parts. So at the end of the lab, their yield was a number that was off than they expected. And that's just because they had coiled it too tight. So this is picking your brain to think about what could have gone maybe awry, or I did a little different than I should have in the lab that would have affected the results in the end. And then improvements for further investigation. You can always suggest to do more trials of a lab. The more data that we collect, the more reliable it would be. You can see time and time again if you're getting the same results. Maybe when you're conducting an experiment, it gives you this aha moment of something that you particularly want to test or would want to know what the results would be. And so this is a great place to type that in there. Okay, so we've got 4 main parts when we're making a lab report. We've got the introduction that's got a couple pieces in it. We've got the materials procedure. You've got the data that may include like a table or a graph in addition to what you had to fill in for the lab. And the last part is the analysis. So I hope that this helps. Just remember that the lab reports are a little more lengthy, and I'm looking for you to spend a little bit more time to make these a little more substantial than some of the other assignments. If you have any questions, I am happy to help. If you can't find the lab report template guide, let me know and I can share that link with you. I hope you have a great day.